Today we are having a question, and the question is from the topic of quadratic equations, and the question asks us that let alpha and beta be the roots of equation. The equation is given to you, and it is asking that alpha to the power 14 plus beta to the power 14 equals. Okay, this is equals. Then what we are going to do is, first of all, we will be finding the roots of this quadratic. Okay, so when you will apply the formula for finding the roots, you will get it as root 2 plus minus root 6i upon 2. Now from here, alpha is equal to root 2 plus root 6i upon 2, and beta is equal to root 2 minus root 6i upon 2. Now we need to express both of them in Euler's form. Okay, so we know that in the Argand plane, this is imaginary axis and this is real axis. Okay, so for the first case, this length is equal to root under 6 and this length is equal to root under 2. Okay, so this triangle will be something like this, and this will be the angle theta. So tan of theta for the first case will be equal to root under 3, and that is equal to theta equals pi upon 3. Okay, so this can be written as, and the modulus, if you will calculate the modulus, a modulus would be equal to root under 2. You can calculate it. So root under 2 into e to the power I pi by 3. This is the first root. And coming to the second root, it will be something like this, because see, the imaginary part is negative and the real part is root 2. So the imaginary part will be on this axis and the angle will be something like this. This is theta. Okay, and here also it will come to be minus root 3. So going in the clockwise direction like this, the angle will come out to be negative, and therefore root beta can be written as e to the power minus iota times of pi by 3. I hope this is clear. Now once we got both the roots, then we can substitute in place of alpha to the power 14, that will be equal to root 2 to the power 14 into e to the power I 14 pi by 3. Okay, and plus root 2 to the power 14 e to the power minus iota 14 pi by 3. Okay, now if I simplify them, okay, if I simplify them, then root 2 to the power 14 and root 2 to the power 14, both of them can be taken common and can be written as 2 to the power 7. Okay, 2 to the power 7, and this term e to the power I 14 pi by 3, what can we write? We can write this as, see, 14 pi by 3 can be written as 4 pi minus plus 2 pi by 3. Okay, 4 pi plus 2 pi by 3. Cos of 4 pi plus 2 pi by 3 is equal to cos 2 pi by 3, because 4 pi means nothing but only 2 rotations from origin, it will come back to its initial point. Now we need to calculate the value of cos 2 pi by 3. So cos 2 pi by 3 will lie in the second quadrant, that is 120 degree, and in second quadrant the cos is negative. So we can write this as cos 90 plus 30, and that is equal to minus sin 30, that is equal to minus 1 by 2. Okay, So the value of this expression, no, we won't be calculating it here. Let us first of all see this is common and these two terms will be left inside. Okay, e to the power I times of 14 pi by 3 and plus e to the power minus I 14 pi by 3. So what we are going to see here, e to the power I theta plus e to the power minus I theta, what it equals? It equals 2 cos theta. So 2 to the power 7 into 2 cos theta. I hope all of you might be knowing that how this results comes, because e to the power I theta is equal to cos theta plus I sin theta, and e to the power minus I theta is equal to cos theta minus I sin theta. Now adding both of them, these term gets cancelled and we are left with twice of cos theta. Okay, so what we are left with is twice of 2 to the power 7 into cos theta. Okay, and now in place of theta, I know what was the angle given. It was 14 pi by 3. So this is 2 to the power 7 into cos of 14 pi by 3. It was 14 pi by 3. Cos of 14 pi by 3. And we just saw the value of cos 14 pi by 3. Okay, so we can write from here, it will come out to be 128 into 2 into cos of 2 pi by 3, and this can be further simplified as minus 128. So this is the answer for this particular question. Such questions have been repeatedly asked in JEE Mains, and this question was from the April 2023 paper. Okay, so this type of questions are not at all difficult. Sorry, I was talking about this question. This type of questions are not at all difficult, but they are a bit calculative. So you must be attentive while solving these particular questions. Thank you.